Family portrait time. This is all the parts that make up an arbor press. Not that much to it, really. These are all going to get thrown into a tub with a bunch of this stuff and left for 3 days or so. That's Vaporus, which is sort of consensus one of the couple of best ways to remove rust from stuff. People argue over this versus crud cutter rust remover. Vaporus is much cheaper. It may take a little bit longer. A lot of the controversy around those seems to have to do with people who expect it to work overnight or something, and the chemical reaction that these things use actually takes much longer to proceed. That's one of the cool stuff. This is science versus rust. Science wins. I have to go find a container. I don't think I have anything big enough to put the RAM into. I think the rest of it will fit in a medium large Tupperware bin or something. So stay tuned. Derusting is underway. You have to watch carefully or you'll miss it. Seriously, this container has all the parts I showed you in my previous clip, and they've been soaking in the Vaporus for about a day. There are two things I'm going to talk about here. One is the setup and length of soak, and the other is the chemistry, which is quite interesting. The setup is quite simple. This is just a Sterilite 8.5 by 11 bin. It is filled with slightly less than a gallon of Vaporus, and it holds everything including the RAM diagonally. It does not hold the bolster plate. We have to do that in a separate run. It just won't coexist with all the other stuff. The length of soak is a matter of some discussion. The factory site on evaporust.com says that 30 minutes is good for light rust and overnight for heavier rust. Some people report in practice that you need to go longer, and I sort of confirmed that today by peeking inside and seeing that it had a little ways to go, and that if I pulled stuff out at that point I was going to have to do some cleaning. So I'm going to leave it in for at least another day. Before I launch into the chemistry, you really should go read the FAQs on the Vaporus website. There's a lot of good information there about determining when the solution's exhausted, what the capacity is, outlining how the chemistry works, and some information on situations where it works well versus ways of using it that don't work very well. Okay, chemistry geek time. The way this stuff works is very interesting. Some of you are familiar with stuff like navel jelly, which is an acid. Acid reactions are very strong. Not only do they eat the rust, but they'll just continue right on and start eating its way through the underlying metal, which means that you have to carefully control the exposure time. Vaporus is different. It uses a chelating agent, which has the property that it selectively binds to iron. And furthermore, the strength of the binding is such that it will pull the iron out of rust, thereby destroying the rust and releasing oxygen from the iron oxide. But it is not strong enough to pull iron out of the base crystalline metal. So anything that's iron that is embedded in the lattice is safe. So it means it's much less sensitive to how long you leave it in. It will basically run to completion and then stop. Now let's talk about the derusting, because this was a chance for me to evaluate and compare some of the approaches that you see online. One way to derust things is purely mechanical. You know, slather it with some citrus strip and then come along with a wire brush or a scraper, or just wire brush it off and use a needle scaler for some of the fine details. I opted to go for the chemical route because the pinion gear has, all this stuff had surface rust. So the pinion gear had quite a lot of rust in the teeth. You had the surfaces of the daisy plate, which is kind of a complex shape, and you would not easily be able to reach some of this to do mechanical removal, and it might not even sandblast that well. So I checked out various reviews online, and I finally decided to try this stuff, Vaporus. This is a non-acidic rust converter. It's pretty slow acting. You have to leave this stuff completely submerged in the Vaporus for 2 or 3 days. I went for 3 days on everything, and it worked great. People have talked about, oh, this stuff doesn't work very well, and when you read closer, it's usually turned out they were expecting results after maybe overnight immersion or something like that. It's definitely slower than that. I put these parts in for 3 days, and as far as I can tell, all the surface rust is gone. It's just gone. It converts into this black residue, and you sometimes have to lightly wire brush that off. I used a Dremel tool with a pretty fine wire brush to remove most of the remaining black residue from these parts, and they just came out great. The nuts and bolts look like they were new yesterday. So, you know, in my opinion, this stuff works. It works well. It's 20 bucks a gallon. No hazmat shipping or anything. It's much less expensive than the Crud Cutter Rust Remover, which is, I think, fairly comparable chemistry. It's non-acidic, so it's not like the acid treatments like naval jelly. It will not etch the metal no matter how long you leave it on, so you don't have any worries about like trying to precisely control the timing. So it worked very well. I think this is going to be in my toolkit forever. And the parts are fantastic. I'm going to cut over now and I'll give you a little bit of a closer look at the parts so you can see how good they are. And I'm also going to show a detail on this little interesting little decal. That's it for the mechanical parts. Next time we're going to look at the body and paint.